How to construct a half-wave rectifier uses and click on new project. Give the name of the project as half-wave rectifier to find ripple factor. Click on next, 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 finish. So here, click on component mode, pick devices. Here you type transformer. So select simple transformer, click on OK and place in the workspace. And to provide AC voltage source, we need AC voltage source. Here you just type V sign. So click on this and place here. And in order to measure this voltage, whether it is 230 volts or not, we need AC voltmeter. Click on the instruments, select AC voltmeter and place here and join all these things. Sorry. Join here, and this also you join here. Okay, so you have to adjust the amplitude of V sign. Go to edit properties. Here you select 325 point, the amplitude as 325.27 volts and frequency as 50 hertz and click OK. And in order to get 12 volts output at the secondary of the transformer from 230 volts to 12 volts, you need to adjust the properties of transformer. The primary inductance, you should give it as 367.5 Henry. 5 Henry. Secondary inductance as 1 Henry and click OK. And you connect one AC voltmeter in order to check whether we have got 12 volts or not. Connect this to here. You just click on simulation. I'll zoom it. See, input is 230 volts. Since we have adjusted this amplitude as 325.27 Henry and output is 12 volts because we have adjusted the primary winding of the transformer as 367.5 Henry. So why we need to adjust the primary winding and how much voltage we should be given for V sign, that the detailed video I have done and the link of that video I have shared in the description box. Before doing this experiment, you go through that video, you'll come to know how much amplitude we should adjust in V sign and how much primary inductance we should adjust in a transformer. Okay, I'll stop simulation. Now in half-wave rectifier, I need one diode. Click on component mode. So you just type 1N4007. So select the silicon rectifier, click OK and place it in series. And we need one resistor, load. You just type resistor and select this resistor. register, generic symbol register. Click this and place here, and it will come in horizontal mode. Click on right click, go to right click. Before that, we'll adjust the value to 1 kilo ohm. Right click on this and rotate anti-clockwise and connect this to diode and this to register, and from here to register. And we need one ground. Click on ground and place here and do the connection. Okay, so in order to check the waveform, we need CRO, cathode ray oscilloscope. Click here and place oscilloscope somewhere here, and the input should be given to the transformer. In order to check the input waveform from channel A, give it to transformer, and the output waveform you should give it to the register. Okay, so after this you go to view and click on zoom in, little adjust here. Okay, next you click on simulation. So here we will get input 229 or 230 volts, output 11.9 or 12 volts, and you stop the channel C because we are using only channel A and channel B, and adjust the time per division knob. This is time per division knob. So this yellow one is input waveform and output is blue. And this is input waveform, yellow color, sinusoidal waveform, and this is output waveform. During positive half cycle, we are getting output. During negative half cycle, there is no output. Now we will find the VM voltage of the output waveform. So click on cursor and keep your cursor on the tip of your output waveform. It is showing 16.25. Now it is showing 16.25. VM voltage is 16.25. And after this, we will find the VDC voltage. How to find the VDC voltage? First, keep your CRO knob in AC mode and keep your finger on any one of the line on the base of this output waveform. Now, if you press the knob on DC, the waveform will shift upwards by 1 unit. You just see this. So it went 1 unit up, 1 division up, 1 division into 5. So it is 5 volts. 1 into 5 is 5 volts. VDC is 5 volts and VM is 16.25 volts. VDC we got 5 volts and VM we got 16.25 volts. So from this we will find the ripple factor. Ripple factor is defined as the ratio of AC component to the average value of the DC component. But VAC is defined as square root of 𝑉𝑅𝑀𝑆 𝑉𝑅𝑀𝑆 ripple square minus VDC square. In case of half wave rectifier, 𝑉𝑅𝑀𝑆 ripple is given by Vm by 2. Vm just now we found out in simulator, it is 16.25. That you substitute here. 16.25 divided by 2, it is 8.125 volts. That is 𝑉𝑅𝑀𝑆 ripple. And substituting this 𝑉𝑅𝑀𝑆 ripple in VAC formula, VAC is equal to 8.125 minus 5 square, because VDC is 5. So after calculating this, I'll get square root of 41.02. Square root of 41.02 is 6.40 volts. Now we will substitute in the RF equation VAC by VDC. VAC I got 6.40. VDC I got from the simulator 5 volts. So 6.40 divided by 5 is 1.28. This is the practical value of RF. whereas the theoretical value of RF is 1.21. So in this way, you can find out the ripple factor using Proteus in half wave rectifier without filter experiment.